Block 1. The Great Attractor and Dark Flow, Unmasking the Cosmic Mystery. Hello, Cosmic Explorers. Today, we're diving into one of the most perplexing mysteries of the universe, an invisible, colossal force that seems to be pulling entire galaxies, including our own Milky Way, towards an unknown destination. For decades, astronomers have observed peculiar, non-random movements of galaxy clusters, suggesting something massive and unseen is exerting an immense gravitational pull far beyond what we can explain with known matter. This phenomenon, often referred to as dark flow or the influence of the Great Attractor, challenges our understanding of cosmic expansion and the very fabric of reality. We'll explore the initial discoveries, the observational evidence, and why this unseen current has baffled scientists for so long. Imagine for a moment that you're on a boat in the middle of a vast ocean. You expect the currents to move in predictable ways, perhaps with the tides or prevailing winds. Now imagine you notice your boat, and indeed all the other boats around you, are being subtly but relentlessly pulled in a single, inexplicable direction against all known currents. That's a bit like what astronomers started noticing about galaxies in the latter half of the 20th century. While the universe is generally expanding uniformly thanks to Hubble's law, scientists began to detect slight deviations, what they termed peculiar velocities. These weren't just random jitters, they were coherent, non-random movements of vast galactic structures, all heading towards a specific region of space. The first major hint came in the 1970s and 80s, when studies of galaxy movements in our local cosmic neighborhood, the Virgo supercluster, revealed that not only were galaxies moving away from each other due to cosmic expansion, but they also had an additional collective drift. This led to the concept of the Great Attractor, a hypothesized concentration of mass so immense that its gravitational pull could overcome the expansion of the universe on a local scale, dragging galaxies like our own Milky Way, the Andromeda Galaxy, and thousands of others towards it. Initial estimates placed its location in the direction of the Centaurus supercluster, roughly 150 to 250 million light-years away. However, much of this region is obscured by the dust and gas of our own Milky Way, making direct observation incredibly challenging, a cosmic veil known as the zone of avoidance. As observational techniques improved, particularly with the advent of more precise measurements of the cosmic microwave background radiation, the mystery deepened. The CMB, the afterglow of the Big Bang, provides a nearly perfect snapshot of the early universe. Yet, even in this primordial light, scientists found evidence of a large-scale bulk flow of matter extending far beyond the Great Attractor. This phenomenon, dubbed dark flow in 2008 by a team led by astronomer Alexander Kashlinsky, suggests that not just individual galaxies or local groups, but entire clusters and superclusters of galaxies spanning billions of light-years are participating in a coordinated motion. Imagine a cosmic current pulling everything in its path, irrespective of local gravitational tugs. This is where it gets truly baffling. The scale of the dark flow is immense, extending far beyond the observable universe, implying that whatever is causing it must be an incredibly large-scale structure, or perhaps even something outside our cosmic horizon. The initial observations of dark flow were based on analyzing the kinetic energy imparted to galaxy clusters by large-scale structures, which manifested as subtle distortions in the CMB. While the concept of the Great Attractor explained local peculiar velocities, dark flow suggested a much vaster, more encompassing pull. Could these be two manifestations of the same underlying force or distinct gravitational anomalies? The scientific community has been divided, with some studies supporting the existence of dark flow and others finding no significant evidence. The challenge lies in accurately measuring these subtle cosmic movements against the backdrop of an expanding universe and the inherent noise in astronomical data. Yet, the persistent anomalies continue to fuel the search for answers, pushing the boundaries of our cosmic understanding and forcing us to confront the possibility of forces and structures far grander than anything we've ever conceived. The implications are profound, fundamentally challenging our models of cosmic evolution and the distribution of matter in the universe.
Block 2. Beyond the visible. Theories and the terrifying implications. So, what exactly is this cosmic leviathan? In this segment, we'll delve into the leading theories attempting to explain the Great Attractor and the dark flow. Could it be an unbelievably dense concentration of dark matter? A supercluster far larger than anything we've ever imagined? Or perhaps even evidence of a connection to another universe or dimension? We'll discuss the cutting-edge research, the ongoing search for answers, and the mind-bending implications if these theories prove true. Imagine a force so powerful it's dragging everything in its path, fundamentally altering the cosmic map as we know it. Join us as we ponder the terrifying and awe-inspiring possibilities of what lies beyond our current understanding. One of the most widely considered explanations for the Great Attractor's influence, if not the full dark flow, is that it's a massive, previously unknown dark matter concentration. We know that dark matter, an invisible substance that interacts only gravitationally, makes up about 27% of the universe's mass energy content, far outweighing normal matter. If there's an incredibly dense, localized clump of dark matter, perhaps a supercluster of dark matter halos, it could certainly exert the gravitational pull observed. Such a structure would be invisible to our telescopes, but its gravitational signature would be undeniable. The challenges here lie in explaining how such a massive concentrated structure could have formed within the standard cosmological model, and why it would be so dominant. Furthermore, while dark matter can explain local gravitational anomalies, stretching its influence to the scale of dark flow across billions of light years becomes more problematic without invoking an impossibly large and coherent structure. Another compelling theory, particularly for the Great Attractor, is that it's simply a previously underestimated supercluster of galaxies. A truly colossal collection of matter, albeit ordinary baryonic matter, that is simply far larger and denser than anything we've mapped so far. We've already identified structures like the Laniakea supercluster, which encompasses our Milky Way and about 100,000 other galaxies, all gravitationally bound and flowing towards a common center. The Great Attractor could simply be the true gravitational heart of an even larger, more encompassing supercluster, much of which remains hidden behind the zone of avoidance or is simply too distant to fully survey. Recent observations using X-ray telescopes have indeed uncovered massive, previously unknown galaxy clusters in this region, lending some credence to this idea. However, even the largest known superclusters might not be massive enough to account for the full magnitude of the observed dark flow, which seems to extend beyond the boundaries of known cosmic structures. But what if the answer lies beyond our own universe? This is where the theories become truly mind-bending. One speculative yet fascinating possibility is that the dark flow is caused by the gravitational influence of an object or region of space that exists in another universe or dimension. Imagine our universe as a bubble in a larger multidimensional bulk. If another bubble or a massive structure within that bulk were close enough, its gravitational pull could bleed into our universe, manifesting as the dark flow. This concept is rooted in theories like string theory or brane cosmology, which propose the existence of extra dimensions and parallel universes. While highly speculative and currently untestable, it offers a radical explanation for a force that seems to originate from outside our observable cosmos. It challenges our fundamental understanding of space-time and reality itself, suggesting that our universe is not an isolated entity, but potentially part of a much larger interconnected cosmic tapestry. The implications of confirming any of these theories are profound. If it's a super dense dark matter concentration or an unbelievably massive supercluster, it would force us to reevaluate our models of cosmic structure formation and the distribution of matter on the largest scales. It would mean our cosmic map is incomplete, with a dominant unseen landmark dictating the flow of entire galaxies. But if it's a pull from another universe or dimension, then the very fabric of reality as we know it would be stretched. It would open up entirely new avenues of physics and cosmology, blurring the lines between science fiction and scientific possibility. Are we merely passengers on a cosmic conveyor belt heading towards an unknown, terrifying destination? The search for answers continues, with new telescopes and observational techniques constantly pushing the boundaries of what we can see and understand. It is our generation that must continue to unravel these cosmic enigmas. What do you think is pulling the galaxies? Let us know in the comments below. Subscribe to learn more, and see you soon.